Dear students, welcome to this lecture video. Today we are going to cover module 12, which is about cost of capital and valuation basics. This is our first problem. Assume that Medtronic is expected to pay $6.07 dividend per share annually. Estimate its intrinsic value per common share using the dividend discount model. Under each of the following separate assumptions. Assume that the company's cost of equity capital is 6%. Round all calculations to 2 decimal places. The dividend per share occurs at the end of each of the next 3 years, after which there are no additional dividend payments. So question 1. Part A. So we have D1 is equal to 6.07, D2 equal to 6.07, D3 is also 6.07. Now, generally speaking, price means the present value of all future cash flows. So these are the future cash flows. We have to find out the present value of each of them and then add them together. So of course, we can calculate the present value of each of them separately and then add them together. But there is a function in a financial calculator which is called CF, cash flow function, which will be more efficient to use in this type of problems. So I found this calculator online, which is online version of Texas Instruments BA2. So we are going to use it. It is not a perfect replication of our physical calculator, so there are some issues, and I'll mention to you, but I think it will be easier for you to follow if I use this calculator. So the first thing to do is we are going to press CF, which means cash flow. Now we want to erase existing values in this function. For example, if you go down, press this down arrow, you will see 0, one more, 0. So there are no values now. So CF0 means cash flow today. If you go down, C01 after 1 year. F01 means frequency. And I'll discuss this more in a moment. Now let's click on CF again. Now I want to erase existing values. To erase existing values, you have to press second and then this key, CE/C, which basically means clear work, right? So you'll press second, which means clear work. Now, what I have noticed though is in this online version of the calculator, this clear work doesn't work. But in your physical calculator, it will work. So we have no problems for now because we don't have any existing values. So the first thing to do to solve part 1 is we have to enter the cash flows. Now, CF0 is the time indicator. So 0 means today. But we don't have any cash flows today. Because in price, it is the present value of future cash flow. So it starts with D1. And in this particular part, A, we have D1, D2, and D3. That's it. So what we are going to do, we are going to press the down arrow to go to our C01. So cash flow at the end of first year, which is so $6.07, 6.07. After you enter this, it will not be stored immediately. You have to press this enter key. Remember that in your physical calculator. Now, go down. So this is saying F01. So F01 means how many times the C01. So the year one cash flow is occurring, meaning the same amount of cash flow is occurring. So we have how many times? We have 3 times, right? So we are going to enter 3 and then hit enter so that this value is saved, right? Now we are going to press this down. We are going to press this down arrow to check there is no other cash flow. There is none, so that's why it actually circles back to our initial CF0. So we have C01 6.07, which is occurring 3 times. So F01 is equal to 3. You entered 3. Now we are going to press NPV, net present value. You will see this on your display. It is asking for the interest rate because we want to calculate the present value of dividends which go to the equity holders. We need to use cost of equity, which is in this case 6%. So enter 6 and then press this enter key. Then it will be saved. Now press down arrow and compute. So you will get $16.23. So that is our price for part A. Yeah. So key thing to remember then is this is how you have to clear the existing values in the CF function. First, you have to press the CF key, and then second, and then C/C, which basically means clear work, right? And then after you enter each value, you have to press the enter key, right? EN-TER. You have to press the enter key. And then you also have to remember, after you have entered all the cash flows, you'll press NPV, and it will ask for interest rate. And then you will provide the interest rate. Okay, now let us move to part B. The dividend per share occurs at the end of each year in perpetuity. So forever. So in this case, our math is much simpler. If you remember, this is our chapter 12 slides. So if we have a perpetuity, then dividend discount model with a constant perpetuity. The cash flow does not change. So $6.07, and this is the formula. Right? So your D1 is dividend at the end of first year. RE means cost of equity. And then your IV 0 means intrinsic value at the end of year 0, which basically means today. Right? So what we have to do then, because it is a perpetuity, all the dividends are the same. So what we have to do is our dividends, $6.07, divided by our cost of equity, which is 6%, 0.06. So $101.17. So now part C is asking the dividend per share occurs at the end of each of the next 3 years. Okay. After which the dividends increase at a rate of 2% per year. Okay. So that basically means you will have all these dividends, but then your dividend 4 will be 6.07 times 1 plus the growth rate, which is 2%, right? And then your D5 will be D4 times 1 plus 0.02, and so on and so forth. And we have to find out the present value of this and of this infinite growing perpetuity, right? So we cannot use, we can use a financial calculator, and we can also use a math formula. So for example, if dividends are increasing and they are a perpetuity, we can use this formula. So let me write this down here. So now what you see is D1 over RE minus G. Now, so this is only for the part when dividends are increasing. But what we have here, it is a mix of perpetuity and also different cash flow, and also same cash flow for the first 3 years. So in this formula, what you need to notice though is you can find out the intrinsic value today at the end of year 0 if you know the dividend at the end of year 1 divided by RE minus G. Similarly in the previous formula, right? You need the dividend 1 year after D1 to find the value today, intrinsic value. So in our case, essentially then, what we have to do, calculate the present value of all these cash flows, and also calculate the present value of this perpetuity. Now, for this, we can find out the present. One way to solve this is we'll find out the present value of D1, D2, and then we will find out the present value of D3 plus our intrinsic value at the end of year 3. So let me explain this. So our perpetuity starts from year 4, right? Or after the end of year 3. So we need to use this formula for all the dividends after year 3. So we will use dividend 4. So our formula, IV, intrinsic value at the end of year 4, will be our intrinsic value at the end of year 3 will be our dividends at the end of year 4 divided by RE minus G. Now, that is because this value is estimated at the end of year 3, and we also have dividend 3. So we have to add them together and then calculate the present value. So our first step then is to calculate intrinsic value at the end of year 3. So which will be our dividend 4. And our dividend 4, we already wrote it down here, is so 6.07 times 1.02, 6.1914. Divided by our cost of equity, which is 6%, minus the growth rate, which is 2%. So 6.1914 divided by 6% minus 2%, 4%, so 0.04. So which will be 154.785. Okay. So now we have to add this amount to the dividend 3 when we use the cash flow formula in the financial calculator. So let's go to our financial calculator. So again, in your calculator, you'll press CF, and you already have some cash flows here. Now, if you press in your physical calculator, press second clear work, they should be erased, but in this calculator, they are not. So I'll press CF. So this is the limitation of this online version, but that is not an issue in your physical calculator. So first of all, I'll press CF and then second clear work in your physical calculator. And then we'll press down to go to our CF0 and press down. So it should be C01 first. So let me refresh this. It's not working. Now it is working correctly. So press CF. This should be on your screen. Now down arrow should be C01. And then F01, right? And then it comes back to the initial CF0. So I guess we just have to refresh after every computation. So we don't have any cash flow for today. So go down, press the down arrow once, and enter our first dividend. Don't forget to press this enter key. Now, down arrow, how many times are they happening? Remember, we have this happening twice, D1 and D2. We cannot add D3 because we have to adjust the year 3 cash flow by adding the intrinsic value of year 3. So I will enter 2, enter, and then down, which is our 6.07 plus our intrinsic value of 154,785. So plus 154.785 equal enter. Don't forget to press this enter key. Now down arrow, this is happening only once. We don't have any other cash flow, so we are good. press NPV, interest rate is 6%, press enter key, and then again down arrow, it will show NPV, but you have to compute. So 146.19. That is the correct answer. So remember, this is how we calculated the price. Now moving to our question 2. Medtronic PLC's stock recently traded for $239.88. Using the Gordon growth model, estimate the market's expected growth in dividends that is required to yield the $239.88 price per common share. Assume that the current dividend per share is $8.28 and is expected to grow thereafter, and the cost of equity capital is 9%. Okay. So Gordon growth model, what is Gordon growth model? So Gordon growth model is just another name for DDM, dividend discount model with increasing perpetuity. So cash flows are increasing and they're coming forever. And this is the formula. Now, if we use this formula, we can find intrinsic value. But one is intrinsic value, another is market price, right? We generally think if the market is efficient, intrinsic value and market price will be the same. So here, what they're saying, we have to find out estimate the market's expected growth in dividends, which means G, that will give us a price of this. So I'll write down this formula. So our IV, we already have this formula here. So IV0 is equal to D1 divided by RE minus G. Now, what we are saying, we have a market price, P0, instead of intrinsic value. And then we have dividends. The current dividend is $8.28. That means that is the D0. So we don't know D1, but we can use D0 times 1 plus the growth rate. So that will be our D1 divided by RE minus G. RE is cost of equity. Now we have to isolate this G from the remaining variables. So what we are going to do, we are going to take this left-hand side P0, multiply this. So this is on the left-hand side in the numerator, and we'll multiply this with each of the items on the denominator. So P0 times RE minus P0 times G is equal to, now on the right hand side, we have this numerator only, and we are going to multiply P0 with each of the elements within the parentheses. So D0 times 1 doesn't change, so D0 plus D0 times G. So now what we are going to do, we are going to put all the things with the G with them on the right hand side. So this minus P0 times G will be moved to the right hand side. So that will be positive. P0 times G. So now we have on the left hand side, we'll keep P0 times RE, and then we'll bring from the right hand side D0, so minus D0. And on the right hand side, we have P0 times G. On the right hand side, we kept that, and also we brought from the left hand side P0 times G. So now we have P0 times RE minus D0 is equal to, on the right hand side, we are going to factor G. So we will have G times D0 plus P0. And then we are going to divide both sides by D0 plus P0. So that is our value of G. So a little bit of manipulation here, algebraic manipulation here to get to our solicited G, intended G. So our P0 is market price, so 239.88, 239.88, and then times RE, cost of equity, is 9%, 0.09, divided by our D0 is $8.28, and then our P0 again is 239.88. That is our value of G. Let's see how much we get. Let me copy this number first. I'll use, let's say, up to this. So we have to round to 7/4. This number divided by that number. So we have 8.9%. So we might have made a mistake somewhere. $239.88 times 9%, 828. I see, we did not subtract this D0. So minus D0 is 828. So let's do this again. Our numerator is wrong. So we have to subtract 828. Let's see now, and then divide by this number. So 5.5% about. Cent. Okay, now we are going to let me check one more time here. So now question 3 is it is asking an analyst estimates the cost of debt capital for Abbott Laboratories is 3%. And that its cost of equity capital is 8.15%. Assume that ABD's statutory tax rate is 21%, risk-free rate, market risk premium, market price, dividends are. We have to find out average pre-tax cost of debt and market beta. So pre-tax cost of debt. So when we talk about cost of debt capital, it is defined in after-tax basis and represented by this variable RD. And this is equal to our pre-tax borrowing rate times 1 minus the tax rate. So what we have here, we are given the average pre-tax cost of debt. Sorry, we have to find out the pre-tax cost of debt, and we are given the cost of debt capital. So we are given RD, right? So I'll copy this formula here. So our RD is equal to 3%. We have to find out pre-tax, right? So our pre-tax will be then our RD, which is 0.03, divided by 1 minus the tax rate, which is 21%. So which will be so up to 1 decimal place, it will be 3.8%. Now market beta. So market beta depends on the our cost of equity formula. So we can calculate cost of equity capital using CAPM, and you have seen this model many times in other classes. So this is our cost of equity capital. Your cost of equity is equal to risk-free rate plus beta times market return minus risk-free rate. So this RM minus RF is a market risk premium, and beta is the market beta. We have to find out beta. So we have to again do some algebraic manipulation, not anything crazy, a little bit. So question 3. That was our part A. For part B, so we have this formula. We have to isolate beta, which is B. So we'll keep RE, bring RF from the right-hand side, and then we have beta times market return minus risk-free rate. Okay. And we have to find out beta, so we are going to divide both sides by RM minus RF. So we will have RE minus RF divided by RM minus RF. That will be our beta. So our RE, cost of equity, is 8.15%. So 0.0815 minus our risk-free rate, 4.95%, is now divided by our RM minus RF. So we don't have the market return, RM, but we have market risk premium, which is RM minus RF. And that is more than enough for us, right? We know the entire value of the entire denominator. So we just need to divide this by our RM minus RF, which is market risk premium, 5%. .64. Okay. Now this was also under part A. Now for part B, assume that its dividends continue at the current level in perpetuity. Use the constant perpetuity dividend discount model. Constant perpetuity means this. D1, dividends do not change. And this one is increasing perpetuity. So use the constant perpetuity dividend discount model and the market price to infer the market's expected cost of equity capital. So now we have to find out RE, cost of equity capital. So as per constant perpetuity model, this is what we have. So to find out RE, we can swap this numerator with this denominator. So RE will be our D1 divided by intrinsic value of 0. But we don't know intrinsic value. We know price. So we are going to use price. And that's why basically it is saying infer market's expected cost of equity capital, meaning given the market price instead of intrinsic value, which we don't know, what is the implied cost of equity? So our D1 is $326 divided by market price, 184.39. So 1.77%. Okay. Now, Compare the inferred cost of equity capital from Part B to the 8.15% estimated cost of equity capital from the analyst. Actually, I will let you guys think about this and answer this problem. More conceptual. You should be able to answer this. Now I'm moving to question 4. So we have trading at $48.77. Dividends, market beta, average pre-tax cost of debt, statutory tax rate, market cap, price, total farm value, risk-free rate, market risk premium. We have to estimate USP's cost of debt capital, cost of equity capital, weighted average cost of capital, rounded to 2 decimal places. So cost of debt capital, we have already seen this formula, is this. So our pre-tax borrowing rate, how much is it? Let's see. So average pre-tax cost of debt, pre-tax cost of debt, which is 2.4%, times 1 minus the tax rate, which is 22.4%. That includes everything. So 22.4. So this will be actually, let me calculate this one first. So 1 minus 0.224 to this. What happened here? 1 minus 0.224. Now multiply by 0.024. So which is 1.86% for 2 decimal places. Right? 6%. Now cost of equity capital, we have seen that formula too already. This one. Our risk-free rate, 4%, plus our beta, 1.44, times our market risk premium, 5%. Actually, do that part first. Times 0.05 plus 0.04. So 11.2%. Now weighted average cost of capital. So a company has investment from its stockholders, right? Which is equity. So we need cost of equity to discount those cash flows. At the same time, a company borrows money from bondholders, right? So which is debt. So we need to discount debt using the cost of debt. Because a company uses both equity and debt, we need a cost of capital that accounts for both equity and debt, which is weighted average cost of capital. So, and this is the formula for weighted average cost of capital. So RD, cost of debt, multiply by the weight of debt. What portion of the capital has been financed with debt, or in other words, the percentage of debt in the intrinsic value, plus cost of equity times percentage of equity in the intrinsic value. So I'm going to copy this formula, paste here. So we already calculated cost of debt, cost of equity. Weighted average cost of capital is equal to cost of debt, which is 1.86%. Now times value of debt. We will use market value of debt and market value of equity whenever available. Sometimes we don't have information on market value of debt, then we use book value of debt. So in this case, we don't know about market or book value of debt, but what we know market cap, which is market value of equity. So if we subtract the market cap, which is market value of equity, from the total firm value, we will get market value of debt. So 53.6, that is our market value of the firm. In this case, we are using it as intrinsic value of the firm, minus market value of equity, which is 42. That gives us our market value of debt, which is used as intrinsic value of debt, divided by 53.6. So now plus, so this is one part of the formula. Second part is cost of equity, which is 11.2% times 53.6 is the cost of equity. Sorry, 42 is the cost of equity divided by 53.6. Okay, so let us do this calculation. I'm going to start with this part first. 53.6 minus 42 divided by 53.6. This now multiply by 0.0186. So this much. So I'm going to write down, let's say up to, it's a small number, so let's say up to 6 decimal. I'll round it to 3. Now plus the second part. So the second part is much easier. So 42 divided by 53.6, this, now times 0.112, equal to this. I'll use, let's say, 6 decimal places again. And then I'm going to add this part. So which will be this. And up to 2 decimal plus, it will be 9.18%. Now, using the dividend discount model and assuming a constant perpetuity at its current dividend level, estimate USP's intrinsic value per share. So you have to use constant perpetuity at the current dividend level. So constant perpetuity formula is very simple. This is the constant perpetuity. So our intrinsic value today will be our D1, which is our dividend 1.92 divided by our cost of equity, which we calculated as 0.112. So 17.14. Okay. Now using the Gordon growth DDM. So Gordon growth DDM is just another name for this growing perpetuity formula. I don't know why it is not letting me write down C. Okay. So, and assuming next period's dividends equal 192. So current dividend is 192 and next period's dividends are also 192 and grow at a constant rate for each period thereafter. Infer the market's expected growth in dividends that are necessary for USP's intrinsic value. So again, we have to find out the growth, but here we have to use using Gordon growth, and we know the dividend next period's dividend 192. So in the previous problem, if you remember, we had to go through this entire process because we didn't know D1, we knew D0. Now they're saying D1 is the same as D0, so we can directly use D1. So this is our formula again. IV0 is equal to D1 divided by RE minus G. So we have to find out the value of G. So first of all, in case of intrinsic value, write this down. And then I will multiply this numerator with each element of the denominator on the right-hand side. So RE minus intrinsic value G. So we are trying to isolate the G, right? So now we are going to take this part with G to the right-hand side. And then we are going to bring this D1 to the left-hand side. Now we will divide both sides by IV0. So we don't know intrinsic value. Instead of intrinsic value, we are going to use market price. So market price is 48.77. So 48.77 times cost of equity minus D1 divided by market price, which is 7.26%. And I'll let you guys answer this question. So that is it for today's video. I hope you enjoyed it and it is helpful. I will see you in the next lecture video. Thank you very much. Have a great day. Bye.